Hi, I'm Paul Kyogan from GKTuition, and in this video I want to go through a Leaving Cert Higher Level exam question. Now the question I've chosen to go through is 2017 Paper 1 Question 3 Part A. In this question we're told that f of x is 2 over e to the x, and that g of x is e to the x minus 1. I'm given my domain of 0, 0.5, 1 and ln 4. So once I know my domain and I know my function, I can sub in my domain into my function to find the corresponding y values. Now it asked me to leave it, where it applies, it asked me to leave it to 2 decimal places. So just in a question like that, make sure if it says to 2 decimal places that you don't go any further than that. So the values for A part 1, my marks are going for these values. Now for part 2, we're given a grid and we're asked to plot our coordinates. I want you to be aware in a question like this, clearly the majority of people would have been getting this question right, which means that it probably will be marked a little bit more harshly in June, which means that you need to make it as clear as you possibly can. So notice how I've done this in 2 different colours. In red I have my g of x and I've labelled it as g of x. In black I have my f of x and I've labelled it as f of x. I've plotted my coordinates and I've drawn circles around each coordinate so that they jump out at the examiner. Now obviously yours should be a lot more accurate than mine because I don't have the grid, but I would label the x-axis and the y-axis as much as possible. So the devil is in the details in a question like this. Now for part 3, it asks me to use the graphs to find the value of x for which f of x is equal to g of x. Well, clearly f of x is equal to g of x here. It's the point where they intersect. Now if it says use the graph, that implies that you should actually draw something in on your graph. So to find the value of x for which f of x equals g of x, I would use my ruler and draw a broken line down to my x-axis. Now if your graph is accurate, this should be working out as about 0.7. So my value for that one is, I'd say the value of x for which f of x equals g of x is x is equal to 0.7. Okay, so in part B of this question, we're going to verify what we did in part A. It asks me to solve when f of x equals g of x. Or in other words, find x when f of x equals g of x. So in A part 3, I worked out that that's about 0.7, and now I'm going to verify it by using algebra. So clearly this method is actually a bit more accurate. So I have 2 over e to the x is equal to e to the x minus 1. So I just need to ask myself, what is my immediate complication? My immediate complication in this case is that I have a fraction. So what do I need to multiply this by in order to get rid of my fraction? Well, in this case, what I want to do is I want to multiply both sides by e to the x. If I multiply the left-hand side by e to the x, I'm just left with 2. If I multiply the right-hand side by e to the x, I'll get e to the x squared, because I'm multiplying this by itself. Minus 1 by e to the x is just minus e to the x. Okay, so now you should notice that you have something to be squared. So I have e to the x to be squared, I have an e to the x, and I have a number. So actually what I have is a quadratic equation. Now in this case, the question is probably made simpler if we use substitution. So at this point, let's just get rid of our e to the x for the moment. So let's do substitution. So I'm going to let y equal to e to the x. Or in other words, everywhere there's an e to the x on this line, I'm going to sub in y. So in this case, my left-hand side will clearly stay the same. Instead of e to the x to be squared, this will become y squared. Instead of minus e to the x, it becomes minus y. Now the reason I did that is because this is just going to be, it's just a lot neater and it'll be easier for me to factorize this quadratic equation. So what I want to do now is subtract 2 from both sides. So I can say that 0 is equal to y squared minus y minus 2. And now I can just factorize my quadratic equation. So if I get the factors of my quadratic equation, it's going to be y minus 2 and y plus 1 equals 0. Okay, once I have my factors, I now want to solve it. So that means if I know my factors, in order to solve it, I let each bracket equal to 0. So I can say that y minus 2 equals 0, which means y equals 2. And I can say y plus 1 equals 0, which means y equals minus 1. But remember, I have no interest in y, because I just plucked y out of my head. Y wasn't in the question, so it's no use to me to actually find the value of y. What I want to do is find the value of x. So I need to continue on and go further. So let's continue this over on the right hand side. So in the first scenario, I can say that e to the power of x is equal to 2. If y is equal to 2 and y is equal to e to the power of x, then clearly e to the power of x is equal to 2. If my unknown is in the power, that means I have to introduce logs. So I can say that ln e to the power of x is equal to ln 2. Now remember, the reason that we introduce logs is because now we can apply our rules of logs. If you go to page 21 in your log tables, your rules of logs are in the middle column, and the third rule is that if you have log of something to a power, you can just bring the power in front. So this becomes x times ln e is equal to ln 2. ln e is just 1. So that actually just means that x is equal to ln 2. And if you put ln 2 into your calculator, you'll get x is equal to 0.69. So all I did there was ln e is just 1, so I can ignore the ln e. ln 2 is 0.69. So x is equal to 0.69. That's our first value. Now you should go back and look at your second one. I have y equals minus 1. But e to the power of something could never be negative. E to the power, so let's say x was minus a million. E to the power of minus a million, it's still positive, it's just really, really, really small. But it'll never be negative. E to the power of something can never be negative, which means I have to ignore my negative answer. Which means y equals minus 1, I can just ignore it. So I only get one value in this case. We can clearly see from our graph that f of x and g of x only intersect once. So there should only be one answer for this. And then if you double check, if you go back, A part 3, we said that our x value was about 0.7. So clearly our graph was quite accurate if when we do it algebraically, we get x is equal to 0.69. Okay, so again, I hope this video made sense. If anyone's unsure of any of that, again, let me know in class during the week or send me an email and I'll try and explain it differently.